All right. So this week you guys will have chapter 9 and chapter 10. And then you have the homework assignment here. And since we didn't have class Monday, I'll kind of get you started on this one and give you some caveats as to what you might find in here. So in let's see, chapter 9, this is going to be working with files. A lot of what you guys are going to be using this for is if you're trying to save any information out or you're wanting to read a file, save a file, etc. The main thing you'll need to know is file paths. And so in Python, the main thing that gives us a little bit of struggle inside file paths is dealing with Windows versus Mac versus Linux and how those file systems operate. In Windows, you're going to see something like C:/, right? That's your root folder. The root folder is C:/, may also be called the C drive. In Mac and Linux, it's going to be the root folder is just / in there, right? So the book is going to focus on the Windows style. If you're using Linux, you just need to adjust your paths as you go through there. Slashes mean different things. So / versus /, those will mean different depending on the operating system. What's nice is Python can automatically determine which ones it should be using. So instead of you hard coding that it should be / because you're on Windows, or backslashes rather, that Python will use this pathlib library and use the path function in order to create that based on whatever operating system it's being executed on. So we will typically use from pathlib import path, and then from path, you just pass it a comma separated value of the different folders it should be going into, and it will automatically create the right structure for that. All right. So you'll see something like this where you import path. Then from your list of files or the files you want to go through, you do a simple for loop for file name and my files. And then for each one of those, you tell it to build a path going for each file name, right? So we're using file name inside of our for loop, and that's going to grab this, therefore giving us the full title of the file we want to open. Again, you can tell it to use slashes and do it overly. It's going to take care of that for you. The important part here is your current working directory. So when you first open up files using Python, it's going to use the current working directory, aka wherever you launch that file from. So by default, you guys have seen this. If you open up idle and you try to save a file, it by default saves it where? So if we go to new file, type some gibberish, and we try to save as or save, it tries to put it in our Python running location, right? And that's where I tell you don't save it there. Always put it down in your desktop or my documents folder, etc. So that is your current working directory. When you launch idle, it's going to be running in this directory here. You can figure out what directory that you're currently in by going out to import OS, and then you can use path.cwd. That's going to give you the full path that you're currently running in. So in the author, they're going in the app data local Python 3.7. In our case, we're going to have something like 3.12 going out, right? If we want to change the directory to something else, like your My Documents folder or desktop folder, you could use the os.chur or chdir, and that's going to allow you to pass in a path, and that will change the current working directory, right? So if your guys' midterm projects, final projects need to work with files, and you need to save files out or something like that, this is the kind of information you'll need to know for that particular project. Okay. If you try to change the directory to something that doesn't exist, you're going to get an error, which means we should what? Instead of getting an error, how can we make sure that if it's an error, we catch it so that our program doesn't crash? Anybody remember that tool that we used from the beginning? So it's try and accept statements. You would try to change this directory. If that doesn't work, you're going to get an error. So you could do an exception on file not found error, and then you could actually write out to the user that does not exist. That way your program doesn't crash. So if you guys are writing something out, it would look something like this. Steal this code here. Instead of putting something like this in your program, you do something more like try. Okay. And if it works, great. You can continue on with your code. Otherwise, you could do an accept, and you could accept on that specific error, file not found. And then you could print out to the user that directory does not exist. And if you were asking them to put that in, and then you're trying to change that directory, you could have this in a while loop where it'd go back and ask them to give them another file input. Okay. Let's see here. There is an os.get CWD. This is an old way of getting the current working directory. Everything now exists around this path. So if you guys are out Google searching, trying to figure out how to work with files and such, it's probably going to deal more with the OS way, which is the old way. You will want to make sure to use pathlib. The benefits of pathlib is it works across any operating system. In the old days, we would have to use OS. We would have to check if we're running Windows, Linux, Mac, whatever. Then we would have to change our complete command set, which means our program got really long. We had to write it for 3 different operating systems. Where now in Path, that's all baked in. It automatically detects what you're using and changes everything accordingly. All right. If you go to your path.home, this is going to send you out to your home folder. In Windows, that's going to be something like your users al or users JSON, whatever system I'm particularly on, right? In Windows, it's in the C drive. In Mac, it's going to be just /users. And in Linux, we call that the /home folder. The real piece that you guys need to understand is absolute and relative paths, all right? A absolute path means I give you the full working directory. So I'm going to go to C::bacon fizz spam.txt. All right. If I'm currently in the bacon folder, then all I have to do relative is go under the folder fizz, under the folder or under the file spam.txt. The idea behind relative paths is it starts in your working directory, wherever that may be, and then how do I get to there from here kind of thing. Where absolute path, I have to build the entire path out. So when we get to homework assignment 4, you guys want to use relative paths, meaning don't put the entire directory structure for the file name. You guys are going to download a text file. When you download that, you have to import that into Python. Make sure you don't use the full working directory. You've just used the name of the file, right? If you use a full working directory, it's going to sound something like C users, JL, Zeller, etc. Well, what happens when I try to run that on your machine? Yeah, I'm not on your machine, right? So it's going to crash. So if you just use a relative path, meaning that that file has to be in the same folder as you're running the Python file, then everything runs fine. That's why we like relative paths as much as possible. All right. So that's the main difference between relative and absolute. Absolute, you're going to have the full file name, where relative is just going to be where it's relative to your current working directory. All right. If I need to go back a folder, so for example, I'm in bacon and I need to get down here to eggs. Notice it's on the same path structure, right? That means I got to go back to C and then down to eggs and go into the eggs folder. A single dot means that you're working in the same folder that you're currently working in, where a double dot is going to mean that I got to go back a structure and into a new folder from there. That's kind of stuff that'll be on the quiz or something like that this upcoming, not this week, but coming up. So single dot means in the current folder, double dot means go back a folder. Anybody got any questions on that part? Okay. If you need to create a new directory while using Python, we use makeDirs. So you'll import OS, you'll use os.makeDirs, and you need to pass it the full file name as it goes through there. So this will create delicious walnut waffles as long as those files are in there. If neither one of those exists, it's going to create every single one of them. Right? You could also do that with the path module as well. So you could do from pathlib import path equals, and then your path, and use a .makeDir, and that will create one directory. The difference between these two is this can only create one directory, assuming this path exists. This one will just blast out every one of those folders. So the real problem with OS is it can really mess things up and it can blow away your file system if you're not careful. So you want to be careful when you're using OS. Path is a little more forgiving when it uses its stuff. All right. We have our absolute paths. I'm just going to skip to the parts that really matter to you. When we talk about the different file structures, I believe there's a question on the quiz that goes somewhere around here. So you will have the C drive. Your anchor is the C drive plus the slash, depending on which folder structure you're in. Your parent is going to be this C user's AL, for example, and then the file name is what falls underneath of that. And within a file name, you have the stem, which is this first part, and then you have the suffix out here at the end, depending on the file type. Okay. Let's see here. There's a bunch of other commands in here to go find, the file sizes, how to make a list of all the different files that are inside of there. If you're searching for specific files, all of this is going to have really good information. All right. There's a couple different ways to write text and do things in here. So for example, from pathlib import path, then we're going to open up the file spam.txt. And if we want to write the text out to that, we would use p.write text. We could write out hello world, and it's going to give us the number of characters that we wrote. From there, we could also read in text with p.read text, and it would read that object in there as well. Okay. If we want to open files, this is what you guys will need to do on your homework assignment. You would do something like hello file equals open home path and then slash hello text. This means that this hello text file is in your home folder. All right. You wouldn't do this if it's a relative one. You would just have hello text. That's it. So unless you need to build out a path, you don't need this section here. So if I open up Python and I'm trying to run this from the example directory that I'm in, I just need hello text. We'll cover that for assignment 4 here. If you need to open it up in some other folder somewhere, you need to pass the full file path through. Right? To read the contents, once you've opened this file, right? So we called it hello file. We give it the text file or the file name that we want to read in. That hello file, we need to then do a read on, and we need to read that into something like hello content. From there, we can just read hello content, and it's going to read in all the text that's inside of there. If we want to read on every single line, which is exactly what we're going to need to do for assignment 4, you will then pass in the file name into the sonnet file or whatever you want to call it, and then do sonnet file.readlines. What that does is instead of reading in the blob of text, everything all at once, it's going to read in every single line out of the file so that we could then search through every single line later on with regex. So for the homework assignment, you're going to do this part, not this part, because it's going to be in the same directory. We're going to use relative paths. And then you're going to use read lines in order to create a list of all the lines of all the text that's in that file. If you want to write a file out, you need to open the file, give it the file name, and then you have to pass this W at the end. Implicitly, there is a R here, which means it's read only. If you use a W, that means it's going to be able to write to the file. Okay. When you open it with a W, we can write text out to it like this. It's going to give you the total number of characters. And then you can use .close to close the file. You always want to read the text in, save it on read lines, close the file. If you're going to write text out, you need to open the file, write the file, close the file. If you don't close the file, there's a chance you'll corrupt the whole thing. So you always want to close the file at the very end. So this is similar to what you're going to be doing for the homework assignment. You're going to open up a file and you're going to read in text from that file. You're going to use read lines in order to store that. And then on the right part where I tell you to write this all back out, you're going to take all of that text that you have modified. You're going to open up a new file with the W, and then you're going to write that out. You could also use write lines. So in the case of the homework assignment, you're going to use write lines because it's in line format. It's a list of lines. All right. There's other ways to save data. So there we're just saving text out to a file, right? But say we need to save a bunch of variables like the name of your cats in a list here, right? We could use the shelf module. This is a way of storing data. If you have it in Python and you want to be able to store it so you can restore it every time you open up the file. For example, say you guys have built a movie library in your midterm project, right? You built up the library, it's imported everything in, but you want to save that so it doesn't have to reload it every single time. You could use something like the shelf module to do that. Right? With shelf, you're going to import shelf. You're going to do shelf.open. You're going to save it out to some file name. You get a cats as your list, and you're going to do shelf file cats, store it as cats, and then you can close it. Then if you want to read it back in, it'll read it back in. The only problem with doing shelf is it's going to create like 4 files for it to do it. It's a lot to keep track of, and it's kind of a pain. You can't really right click and edit those files. So the better way to do that is to use the pretty print p format function. And what this does is essentially you have a cats directory, right? So we have a cats list. And then for every one of those cats, we have a dictionary of all their descriptions. Sounds a lot like what we would do with a movie or a roster or something like that, right? You would have a roster with their name, their number, something like that, as if you were building that for your midterm project. You would have a list of all these different things. Another example here would be the Ford project, if you guys remember that. We had a dictionary for every single car that had every single description in it. And then we had a list of all the overall cars inside of there. You're going to take this P format and say cats. That's going to basically write that out as text. You would open up a file called mycats.py. Notice this is a Python file. You would then write this to open it up in write format. And then you could write this directory out using this. What this does is create another Python file with all your dictionary information in it for you. Right? So you could have starting information. Again, say you built I'm going to use the movie example. Say you use a midterm project that is storing all your favorite movies and a bunch of different information about it. You have that written out for some of your initial ones, but you want the user to be able to add movies, etc. And you want to save that information because as soon as you close the program, that information goes away, right? So we want to save it. You would use this pretty print format in order to save that information out. Then the next time I load the program, it automatically loads everything out of the save, and I've saved all my information and continue to work. All right. I know that's a lot of information and really high level, but I'm also only trying to cover the stuff you really need to know. So we're not in the weeds about stuff you'll never see in a quiz or exam. Does anybody have any questions on reading and writing files? All right. The main thing you'll need to know when you are reading contents is you would use the open without the W in there, right? The W is going to be for writing to a file. And A means that we're going to append something to the file. So if we open it with W, we erase the file and recreate it. So if there was a bunch of data in there, we open it with W, it overwrites it. If we open it with A, it's going to append it at the very bottom of the file. So say I had a text file with a bunch of text. I wanted to add something to it. I would need to use A, not W. If I use W, it overwrites everything in the file. That is a quiz question. Right? If I open it with nothing there, that means I open it read only. If I open it with an R there, that's the same as opening it as read only. That is also a quiz question. Anybody got any questions on that? Okay. So if no questions, I'm going to go off to organizing files. This one we're just going to kind of look through. So organizing files as a way for us to move, copy, rename files. Again, this is handy if your Python project is dealing with a lot of files in the operating system for whatever reason. You're saving a bunch of stuff, or maybe you're analyzing data from the internet and you need to save a bunch of files out. This would be something you guys would need to know for your midterm final projects. So if you need to copy files, you would set up your structure. So we would set up shutil and OS. shutil allows us to copy files from one place to a next. All right. So the shutil library in Python is what we use to copy files. If we need to rename or move a file, we use shutil.move, and that will move from one file to the next. All right. If we need to delete a file, we use what's called os.unlink. That will delete the file at whatever path you give it. All right. If you use rmdir, that will delete the folder at the path, but it must be empty in order to delete it. If you use rmtree, it will delete the file, the folders, and everything inside of it. It's basically like saying delete everything underneath of it. All right. You have to be careful when you're using this kind of stuff, because if you passed in something like C: with rmtree, does anybody have any idea what that would do? Yeah, the computer science guy over there is like, yeah, I know what that does. No? What does that do? Yeah, it wipes the whole operating system on the machine. You turn in a homework assignment that says rmtree C:, I'll come find you. Please don't wipe my operating system on my machine. All right. So you have to be careful when you're playing with these kind of things. Make sure you're in the right directory. Instead of using these, you should be using something like the send to trash module. And what that does is exactly what it sounds like. It's going to send it to the trash can on your operating system, giving you a chance to empty the trash can or delete it, or the recycle bin if you're in Windows. So we can open a file, write a file, close it, and then we can send it to the trash can. Right. Anybody have any questions on deleting files, moving files, copying files? I don't expect you to memorize those. I expect you to know to go to chapter 10 and go find that. Does that make sense? Okay. All right. Walking a tree. All this does is, if you guys have ever been at a command line, right? Maybe. There we go. I'm in a command line. I can't see what files are in here, right? I have to tell it dir, and I can get a list of all the files that are in this directory. If I need to remove these kind of things or go anywhere in there, then I got to change directory. So a CD would change directory, and say I go into downloads. All right, now I'm in the downloads directory down below, and I do a dir, and I can see all the files that are in that particular download section there. That's very hard to kind of see every single thing that's down, right? I'd have to go into every folder, hit dir, find out what files are in there. You guys are lucky you just use File Explorer and you see all this, right? That's what everybody's used to. If you're walking a tree or doing this within Python, you have to use something to walk all the way through and see what's out there. So we could use something like this, which is importing OS. And then we're going to say for the folder name, the subfolders, and the files inside of os.walk, and we pass it a path that we want it to walk, it will then print the current folder, print the subfolders, and print all the files inside of those subfolders. All right. So this little thing right here, you could create as a function, and it would walk the entire directory tree of everything inside of it. Therefore, it would look something like this. Your current folder is in C delicious. A subfolder of delicious is cats, walnut, and inside the walnut folder is a file called spam.txt. And then inside the cats folder, you're going to see cats.txt, zophie.jpg. You'll in the walnuts folder, you're going to see waffles. And inside waffles, you're going to see butter. Right? It's just going to walk the tree down for you. All right. The next section here is about dealing with zip files. So if you have a bunch of data or a bunch of files that your Python project is creating, and you want to save that into a zip file so that the end user can then easily copy that out, you would use the zip module. So you'll use import zip file. And then from there, we are going to use zip file.zip file. Notice the capitalization's a little different. That will create a zip file. You give it a path name, give it all the files that are in it. You can add things to the zip file, get information about it, the file size, compression size, etc. I won't go into great detail. This is only for people that are going to use it in their final projects. Okay. Extracting a zip file gives you all the information about doing that. Adding, creating, let's see, recreating. You should just be projects right now. It is. This is just a bunch of projects on how you can use zip file stuff. All right. So the only thing you really need to know out of here is, how do I copy and move files? We need to use the shutil library. All right. So if that's on a quiz, how do I add, create, not create, but how do I move, copy, delete? We use the shutil. All right. If I'm deleting files, I can use the os unlink. That will delete a file. rmdir deletes folders. and RM tree deletes everything underneath of it. We don't want to use that. We want to use something like send to trash so that we have the ability to undo what we did. Any questions on that so far? That is a lot of content in 26 minutes. All right. I'm only trying to cover the stuff you guys really need to know. I don't want to harp on stuff you don't. Now, that's 26 minutes. That gives me a time to get you guys started on assignment 4. All right. So I'm going to stop this recording.